Hello students, welcome back. We are going to talk about a very interesting sensor and its application in this video, and that is ultrasonic sensor. So what exactly is ultrasonic sensor? Here we are going to send ultrasonic sound waves from the transmitter. Any object which can reflect the sound wave, like a wall, a water surface, a human being, anything, a water bottle also, they are going to reflect those waves back to our transmitter. We will receive them and convert into electrical signals. So this sensor is going to help us in measuring the distance of that particular object from our sensor. So how does the sensor looks like? This is the generic ultrasonic sensor that we use for Arduino projects, and this is HC-SR04. There are 4 pins, one for ground, one for VCC, one for trigger, and one for echo. So how does this sensor work? From the transmitter I am going to send the sound waves at every repeated time interval. That particular sound wave is reflected by the object and received at the receiver. So I can measure what was the time difference between transmitting and sending. So I have the time and I know what is the speed of sound waves, that is 330 meters per second. Now I have the time, I have the speed, I can get the distance. That distance is actually the distance which is traveled in going to the object and coming back to the sensor. So we should divide that distance by 2 to calculate the actual distance of the object from the sensor. So how do we use this in our circuits? We are going to test on Tinkercad now. So in the Tinkercad library, when you scroll down, here is ultrasonic distance sensor. When you drag it, you are going to observe the first major difference, that there are only 3 pins as compared to the 4 pins that we had shown. So that is all fine. You don't have to worry because this is a simulation environment, but in the actual environment you will be using 4 pins only. Now, how do we operate this sensor? First of all, let me just start the simulation. And when you click on this sensor, you can see that there is an object here and it is already telling me that what is the distance from this sensor. It is showing in inches as well as centimeters. So the range is somewhere around 30 centimeters to a maximum of around 2.5 or 3 meters. This is the range of this ultrasonic sensor. Depending on the quality of sensor, you may get less and high ranges also. So now we know that this sensor is directly going to give me the distance in centimeter or inches. Let us integrate it with one of our circuits. So I am going to take the Arduino board and I am going to go to the coding part. In the coding part, here we have the ultrasonic sensors in the inputs. So here we have read ultrasonic sensor at trigger pin. Okay, so now let me show you this by dragging it a little bit on this side. Read ultrasonic sensor trigger pin. There will be one pin which will be used as trigger, and echo, whether it is same, or when you are going to work with actual sensor, there will be 2 pins, one for trigger, one for echo. So then you can say my digital pin 3 is for trigger, digital pin 4 is for echo, and unit is in centimeter or inches. Otherwise, for simulation purpose, you can say it is same as trigger, because simulation can work without those practical constraints. So this is how I am going to read my ultrasonic sensor values. Okay, now let us make the circuit connections first. We'll hide the code, and here we have our sensor. 5 volt and ground first. So ground we are connecting to the ground pin. Ground is available on this side also. Then we are going to connect our 5-volt signal, which is available on the other side of the board with a red color, and signal can be connected to any of these pins. So I am connecting at 9. So now we come to the coding part and we say this is pin number 9. Okay, now we go to control and we will take one simple if else, and we say if this read value, you can drag it, in centimeter is less than, equal to, greater than, you can choose anything. If it is greater than, let us say 60 centimeters, then what should we do? Then we say okay, the built-in LED should be high, otherwise the built-in LED should be low. When you look at the text part of this code, here you have a declaration of a long kind of variable which is dependent on two input parameters, that means trigger pin and echo pin. It is going to take the inputs from your trigger pin and echo pin, set them as output and input pins, and measure the distance. Every 10 microsecond the waves will be sent, and this distance will be returned in the form of a value. Now we are saying that the value which is returned, that is read ultrasonic distance, it will be multiplied with 0.173 to convert it into centimeters, and if you want to convert it into inches, then the number is 0.6783. so you can decide whether you want to work in inches or centimeters. If this value in centimeters is greater than 60, then digital write 13 as high, else 13 as low. So this is the code. Let me hide the code and we run the simulation. So we can now click on the sensor and see that the value is 44 centimeters. It is less, so this built-in LED is off. And as soon as I cross 60, anything above 60, the built-in LED will be on. So if I come below 60, the LED is off, and anything above 60, even at 60.1, the LED is on. So that was a simple yet interesting demo of ultrasonic sensor, and now you can imagine what can you make with this sensor. A lot of things can be detected and lot of applications can be developed. We will do that in our next module, but before that we'll talk about temperature sensor in our next video. Thank you.